Okay, Aditya, am I audible and visible? Perfect. Thank you so much. So, hello everyone. Welcome to the channel of IEEE Student Branch Chapter of Netaji Subhash Engineering College. My name is Hoymanti Datta and I am from the Computer Society and the Department of Computer Science and Engineering, second year. I would like to warmly welcome you all to this talk focusing on the theme of conceptualization of blockchain, application, and related security fundamentals. This event is organized by IEEE Computer Society Student Branch Chapter in association with GNX-CSE of Netaji Subhash Engineering College. Today, we have with us esteemed Professor Dr. Rajdeep Chakraborty. He is an assistant professor in the Department of Computer Science and Engineering at Netaji Subhash Engineering College. Dr. Rajdeep Chakraborty did his PhD in CSE from the University of Kalyani with an MTech in IT and BE in CSE. His research experience is of 9 years and his academic experience is of 14 years. He has several publications in reputed international journals and conferences. He's also written an authored book on hardware cryptography. His field of interest is mainly in cryptography and computer society security. He has also guided many master's theses and UG projects. He is an enthusiastic and budding researcher in computer security. He is also guiding PhD scholars under MACOUT, formerly WBUT, West Bengal, India. Among his numerous accolades include the prestigious Adarsh Vidya Saraswati Rashtriya Puraskar, National Award of Excellence 2019, conferred by Glacier Journal Research Foundation, Global Management Council, Ahmedabad, Gujarat, India, and it was conferred on 10th December 2019. He is also the nominated secretary of Indo-UK Confederation of Science, Technology and Research, London, UK. So, without further ado, please welcome Professor Rajdeep Chakraborty.
Yeah, thank you.
Good evening,
Shall I
sir.
start? Good evening.
Yes, so before you start, I would like to state that this talk is delivered in three parts. Will be delivered in three parts. Well, blockchain principles will be covered first. And in this part, what is blockchain, why it is needed, components of blockchain, private blockchain, construction guidelines, consensus algorithms, smart contracts, and some case studies will be discussed. In the second part, a specific application that is cryptocurrency will be covered. What is cryptocurrency? Top 10 cryptocurrencies, some light on Bitcoin, and some comparative studies. Well, without the security aspect, blockchain and cryptocurrency cannot be delivered. Thus, in the final part, we will go through the cryptographic fundamentals, which is specifically for blockchain, modular arithmetic, block cipher, crypto hash, and Merkle tree. So without further ado, the screen is all yours. Thank you.
Thank you. Thank you. So let me share my screen. Okay, am I audible and my screen is visible? Hello? Okay, so let's start with today's topic. So today I will be basically giving you the fundamentals or uh, concept concepts on blockchain and specific application that is of cryptocurrency and security fundamentals. I have made this talk particularly for our for student branch. The roadmap of this talk is like that. In the part one, I will be covering blockchain principles. That is, what is blockchain, component of blockchain, public and private blockchain, construction of blockchain, consensus algorithm, smart contract, and stepwise guide to become blockchain developers. Okay, so students are really will be interested for become a blockchain developer. Then in part two, I will cover cryptocurrency, which is an application of blockchain, and its definition and features of cryptocurrency, advantages and disadvantages of cryptocurrency. Then I will study the crypto economics with top 10 cryptocurrency and some market study. Then I will give Solana and Cardano developers network concept, which is the fastest growing blockchain platform, and they have also their own currency, cryptocurrency, and then some light on layer 2 lightning network. Okay, and finally in part 3, I will be giving you idea on block ciphers, crypto hash, and marklet tree. Yeah. Now, first of all, why blockchain is needed? So, if you see, there are some shortcomings of server-based system because you force to trust. So, whatever server is giving you the result or whatever server is telling you the data, you are forced to trust. Again, it is a single point connection failure. Okay, so nowadays distributed servers are there, but every server has some specific task to do. So if any server fails, then my information is lost, and there is always a central control on files, operating system, users, etc. So these shortcomings come up in the blockchain with the advantages of the blockchain. For example, it is a trusted system of network which facilitates decentralization. This is the main concept. So you will understand when I will be going deeper into the blockchain. Then transparency, that is blockchain is visible. That is data is visible to everyone participating in that blockchain. Then security is obviously there in the blockchain, and encryption and crypto hash. Traceability is there. So traceability is another important aspect. That is, whatever data is stored in the blockchain, which is traceable. Immutability is there. So immutability means we cannot alter a data once the data is fixed in the block. And blockchain also work in trustless systems. Okay. Now coming to the blockchain. So what is a blockchain is? Basically, what is a blockchain? So basic definition is blockchain is a system in which a record of transaction are stored across several computer nodes which are connected in a peer-to-peer network. Peer-to-peer network means every node is connected to each other. Okay. Now, if you see, it is a just an example or conceptual diagram of blockchain. So, a blockchain consists of, so this is basically a block. So, it is a block 1, block 2, block 3. So, it contains an hash, that is the previous hash and the current hash. Previous means if this is the hash, then it contains the hash of this total block and also this block. Okay, then timestamp is always there, other information are there, and finally data is there or transaction data is there. Okay, so basically you can think of a linked list. So you have already studied a linked list. So similarly, this is a node in a linked list, and every nodes are connected, but blockchain is much more than linked list. Okay, now coming to the blockchain. So here we have a chain of block. Now this is not only blockchain. Blockchain is basically storing the blockchain in different aspects. So one thing is storing in the same shared memory. So this chain of block is shared in in a common memory, and every node can access it. Or this block is stored in every node. So this is basically a blockchain architecture or blockchain. Okay. Now, what are the components of a blockchain? Basically, what are the main components of a blockchain? So obviously, first is storing and retrieving of data, which is the property of traceability. I just told you. And another component is block cipher is needed for confidentiality, signature, and all these things. And crypto hash is needed. So crypto hash algorithm is such that which make the blocks immutable. So if anyone altered the block, then crypto hash will not match. Okay. Then consensus mechanism is there. So consensus mechanism means there are several nodes. So one node, suppose I want to add a block in our participating, I am a participant in a blockchain and I want to add a node. So what should be the consensus? Means what is the mechanism that all the nodes should agree that yes, this block is true and can be added in the blockchain. Okay. So this is known as consensus mechanism to code the business rule. And finally, blockchain based application. So we have many blockchain based application. You have heard that is in the field of medical and others. Okay. So basically, blockchain stores the data, and smart contract are business logic and some other programming softwares which takes the data and give you the services. Okay. Now, what are the player in blockchain? First is blockchain user who are using this blockchain. Suppose if I am purchasing a Bitcoin or selling a Bitcoin, then I am a blockchain user. And blockchain developer, they are hardcore programmer. Okay, so they develop the blockchain network operator. So obviously, blockchain are network based. So there exists a network operator which maintain the blockchain. Data processing and data sources are another component player of this blockchain, and security provided, that is key management certificate, all these things. And finally, the most important player is miner who validates a blockchain based on the consensus mechanism of that blockchain. Okay. Now blockchain are basically of two types. One is public blockchain and another is private blockchain. So coming to the public blockchain, so public blockchain is a type of blockchain which is completely open and anyone can join and participate in the network. So obviously, best example is cryptocurrency or Bitcoin. Not all cryptocurrencies, that let's take Bitcoin. So it is a public because whenever I want, I can enter and do transaction in the Bitcoin. Okay. So all transactions are public and all nodes are equal in this public blockchain. And now in public blockchain generally have open source smart contract. Okay. Because the smart contract are open source and basically cryptocurrencies are public blockchains. So just I told you, cryptocurrency is a public blockchain. And public blockchains are again of can be of two type. One is permissionless blockchain or permissioned blockchain. That means your blockchain is public. Okay. That means your blockchain is public. So it is permissionless or permission. So buying a cryptocurrency, you do not need any permission because it is open to all. And some blockchains are there where you need to first a permission to enter in the blockchain. Then this total blockchain will be open to you. So in public domain, there are basically Bitcoin, Ethereum, and Litecoin. Okay. So these are some examples of public blockchain. Now coming to the private blockchain. So private blockchain is a blockchain which is governed by a single entity or nodes are added through invitations. Okay. Okay. Here also decentralization is there, but everyone cannot enter. For example, Apollo Hospital have made a blockchain based application for its patients. Now, if I am not an patient of an Apollo hospital, then I will not be allowed to access their blockchain. But when I will be a patient, or I will be any member, or I will be a doctor of a Apollo hospital, then I will be allowed to enter the blockchain, and then this blockchain will be accessible to me. Okay, obviously through programs or smart contract. Okay, so it is a closed network, and nodes have specific right and restriction. Okay. So managing data, accessing data, and auditing data. In private blockchain, so there are nodes. So in the very first diagram, I have told you that blockchain are maybe a shared, or it can be stored in different nodes. So there are nodes. So nodes have some specific work. Okay, managing data, accessing data, and auditing data. The data are protected by hierarchy of encryption. So in private blockchain, data are protected by very encryption, because without protecting in hierarchy of encryption, this managing of blockchain will not be possible. Okay. So for example, in server managing something, you need another user ID and password. Everyone cannot access everything. Okay. So similarly, this concept is there. There are always these are always private blockchain, and obviously private blockchain because it is sorry, it should be a permission blockchain. Okay. For example, best example is private blockchain is Visa keeps its transaction in a blockchain, and if we can see that every second they perform 24,000 transactions on average. And Hyperledger Fabric by Linux Foundation, which was developed in 2015, and hybrid blockchain system consists of public and private. So we have studied two types: public blockchain and private blockchain, and hybrid blockchain is there. Basically, in hybrid blockchain, two blockchains are kept. Okay, one blockchain is public, one blockchain is private. So basically, these are hybrid blockchain. Now coming to the concept of constructing a blockchain. So we came with the fundamentals of the blockchains. Now, how this blockchain is actually be constructed? Okay. So first is, whoever wants to a blockchain developer. So first is to identify a suitable use case. That is, in which application area this blockchain is needed. So what are needed? Data authentication and verification, smart asset management, smart contracts. Okay. So all these are needed to identify a suitable use case. Then in the second step, we need to identify the suitable consensus mechanism. So there are various consensus mechanism. Consensus mechanism, I just told you that it is a mechanism so that everyone agree upon adding a new block. Okay, or how blockchain is constructed and maintained. Okay, so this is our consensus mechanism. So these are basically of proof of stake, Byzantine fault tolerant consensus mechanism is there. So you may have studied it is also there in networking. So derived PBFT is there, practical Byzantine fault tolerant, redundant Byzantine fault tolerant, simplified Byzantine fault tolerant, deposit based consensus, federated Byzantine agreement, proof of elapsed time, crash fault tolerance. So all these are the examples of consensus mechanism. Okay. Then step three, identify the most suitable platform. So where you are going to implement. These are the platform where we can implement our blockchain. Okay. So Corda, Ethereum, they are available platform in the market. So you have some are paid, some are some are free up to some extent. So there you have to program and develop your blockchain, and then comes the designing the nodes. So what are the information you are storing in the nodes? So these are the nodes. So basically designing the data, step 4. Okay. Now in the step 5, design the blockchain instance. That is, it should be a permission or permissionless, private or public. Key management is must be there, block signature, etc. Okay. Then building the API. So API is the programs that will access your blockchain and give a result on the basis of API. Okay, and in step 7 we have design of the administration and user interface, and finally in application layer we can add AI in the blockchain, bioinformatics in the blockchain, IoT and cloud applications in the blockchain. Okay, so coming up the examples, so these are some of the use cases. Supply chain management is very important use case used, and various products are coming up in supply chain management. Okay, healthcare, energy management. So I am not going details there. And then there comes consensus. So consensus is a common decision to add a block in the blockchains. Okay, so this is the basically a consensus. So consensus are there are many consensus algorithm are coming up, and one of the most research area of the blockchain is developing a consensus mechanism, a suitable, effective consensus mechanism. So existing consensus mechanism is there: proof of work, proof of stake, proof of elapsed times, and many others. Okay. Now, proof of work. So, proof of work is a type of. So, I am giving three types of example consensus mechanism example. So, first is proof of work. Okay. So, in a proof of work, which is mainly used in Bitcoin and cryptocurrencies. Hmm. So, transactions are broadcast. So, these points are there. I am just explaining with the following diagram. Okay. Let's understand this proof of work algorithm. Okay, so I have a existing blockchain. So in one, I will see this is my existing blockchain. Now I want to add this red one. Okay, in my blockchain. Now what happens in the proof of work? This block is relayed or given to all the nodes or the miners of the blockchain. Okay, and they start mining. Okay, so mining is actually a process based on the consensus of this blockchain, and there is some puzzles are there. Okay, so suppose this miner have effectively mined this block and say that yes, this can be added. Okay, now this block is now added to my existing blockchain, and in reward miner gets another block, or in type of cryptocurrency miner gets. Okay, so basically in proof of work all have the equal right or equal opportunity to mine a block. This is the main theme of the proof of work. And in the proof of stake, it is little bit different concept. So suppose I am in a partner in a blockchain, and I have invested dollar 200. So I have to buy a laptop, or I have to buy a SE, or whatever need. So I have an investment, or I bought some amount of currencies in that blockchain. So based on the investment, so in the same as so same here we have the actual blockchain. We want to add this red blockchain. Now here in proof of stake, we give the highest that have the highest stake in this block. That is dollar 400 will be given first to validate or mine this block. If dollar 400 fails in some amount of time, then it will go to the person who have the next highest stake in the blockchain. Okay, so in this way it will go through all the nodes, and finally if someone verifies it or mined it successfully, then only this block is added, and this and a rewarded block is given to that miner, and obviously this will then increase his stake. Okay, so, just a comparison of proof of work and proof of stake, because these are the mostly used consensus mechanism. Okay, so in the if we come to the parameter of power, then it is ASIC based, and it is higher stake based. Scalability, proof of work is not so scalable, but it is seen that it is very scalable. Security aspect, proof of work is secure. Research is in progress in proof of stake, An example, Bitcoin, Bitcase are of follows proof of work, and proof of stake follows Ethereum 2.0. Okay, and another is another consensus mechanism is there, which is known as proof of elapsed time. So in basically in proof of elapsed times, everyone get blocks to mine for a particular time. Okay, so proof of elapsed time is a consensus algorithm which was developed by Intel. In a proof of elapsed time is likely a lottery system where all nodes have same chance of winning. Proof of elapsed time generates a random wait time for each node, and the nodes with this wait time will go to sleep. Okay, and the nodes within the shortest wait time will wake up first and win the race condition. So this is the how proof of elapsed time works. Okay, now so basically, consensus mechanism are classified in broadly in three categories, but nowadays many other classifications are coming. So one is validation based. So all that I have discussed is a type of validation. Proof of work, proof of stake, proof of elapsed time, proof of activity. So validation means we are validating that that block is as per with the agreement of the blockchain or not. Another type is their validation voting based. So voting based is proof of vote, proof of trust. This voting based means whenever I want to add a block, voting is called. Okay, then if 51% or 50% plus one nodes agree to your block, then this block will be added. Another thing is there, suppose a leader is chosen in every time duration through voting, and he will only allowed to add a block in the blockchain. So these are voting based consensus mechanism. And another is authentication. So you need to authenticate the block. Okay, so using some authentication algorithm. Now, how you would become a blockchain developer? So first is you need your degree. Start with the academics. You need your BTech degrees. Okay. Then you need some proficiency. Okay, this you will develop during this BTech degree obviously. So Java, C++, Python all are now used in various blockchain, and Solidity specifically in the in the Ethereum, and Rust is another programming language which I will discuss in Solana in there. Okay, you should have a very good understanding of data structure. You should have a very good understanding of databases and networking and cryptography. Then learn about crypto economics. So crypto economics is one of the aspects of blockchain, and then you learn blockchain platform. Okay, so there are various platforms are there. Ethereum is there. Okay, so this platform you learn smart contract, distributed apps development, all these things. Okay, then learn about smart contract and Solidity. Okay, how to develop the smart contract, and Solidity is the program through which you can develop the smart contract. Smart contracts are basically algorithms or programs. Okay, then finally there are some hands-on experience available in the internet. So you refer this hands-on. So you can practice there to develop your own blockchain. Okay. So in part one, so we have covered what we have covered. We just understand that blockchain is a distributed ledger technology, and the main component is crypto hash, which makes blockchain immutable. Blockchain can be kept at shared memory also. So public, private, and hybrid blockchain is there. So we need a consensus mechanism, which is a working principle behind creating blocks and maintaining a blockchain. Use cases are basically dedicated application of blockchain. Smart contracts are the codes that provide services to the user of the blockchain. And finally, we came across the stepwise guide to become a blockchain developer. Okay. Now coming to the second part, which is cryptocurrency. So, I am covering the cryptocurrency here. So there are all other various applications are there. That is one of the application is supply chain management. Okay. So now what is a cryptocurrency? So cryptocurrency, if you see the definition, a digital currency in which transactions are verified and records maintained by decentralized system using cryptography rather than by a centralized. So you store your money in a decentralized manner with cryptography. But in if you store your money in a bank, so where it is stored? Obviously stored in bank server. Okay. So this is the definition of cryptocurrency. A cryptocurrency is a digital or virtual currency that is secured by cryptocurrency, which make it nearly impossible to counterfeit or double spend. So one is uh, counterfeit means stealing or double spend. That is, you cannot spend same Bitcoin or same cryptocurrency twice or thrice. Okay, so this is known as double spend. Spend. Okay. Now, available cryptocurrencies are, so we have many cryptocurrencies. Bitcoin is not only the cryptocurrency. So we have Ethereum, we have Litecoin, we have Cardano, Kolkata. So various cryptocurrencies. So I in the next slides I will give you the top 10 cryptocurrency. And one thing you must understand that cryptocurrency are not illegal in India, but they are not regulated. Okay, so this thing is the main disadvantage. Now, basically, this is the node of a Bitcoin. Okay, so in every this is the block of a Bitcoin. So in every block, we have previous hash, timestamp, and transaction root and nonce. Okay, so this is a typical structure of a Bitcoin. Okay, so you made your several transaction. Now this block is created by this marklet tree, and I will discuss with you in the third part how this tree is created. Okay, so this is the typical structure of a cryptocurrency or a Bitcoin. This is a Bitcoin. Now, how Bitcoin works? So if you see, this is the transaction of Bitcoin. So basically what is there, so this is the first owner. So I suppose I am a first owner and you are the second owner. So I will send you my coin. Suppose I have one Bitcoin and I want to send you, or I want to purchase transact 0.5 Bitcoin to you. Then the main aspect is there. I have my private keys and it is the signature of zeros. Means this Bitcoin I have purchased from some other or previous transaction. Okay, so this is the signature and this is the owner first public key. So hash is there and their signature is in the next transaction. My signature is there. So main thing is if I want to send you a Bitcoin, I have to sign this Bitcoin and send it. Okay. So this is the main transaction diagram of a Bitcoin, or it is in the Bitcoin. So what are the main features of cryptocurrency? So we have just shown the how transactions are made. Transactions are made basically by signaturing and hash. So both are there. One is immutability and one is signature. And what is cryptocurrency? Features of cryptocurrency. So cryptocurrency are digital asset based on a network that is distributed across a large number of computers. Okay, it is the outside the control of government and central authorities. The word crypto signifies the extensive use of encryption technique, hash function, and challenge response gain is there in the cryptocurrency. Based on, obviously, cryptocurrency is based on blockchain. And the first cryptocurrency is Bitcoin, which was launched in 2009. Okay, and it is believed that it is launched by Satoshi Nakamoto because he first published this paper, Bitcoin, and after that blockchain technology came. It is interesting to know Blockchain not came before Bitcoin. Bitcoin came before. From Bitcoin, the scientists, computer scientists or computer researchers developed this blockchain technology. And as of March, you see so many 18.6 billion bitcoins are there, which is dollar 90 927 billion. Okay, this leaves a little over 2 million bitcoins to be mined, and now 2 billion bitcoins are to be mined in the blockchain left. Okay, so these values, these 18 million values, obviously change in every 10 minutes. Okay, now why it is cryptocurrency? Because why means why it is a currency. So if you go to the trades of any currency or variable things, you see I have given just a chart of gold, dollar, and crypto. So, and this is the trades of currencies. That's interchangeable, non-consumable, consumable, portability, durability. Okay, these are the traits. Divisibility. That is, if I spend 50 rupees and if I give a note of 100 rupees, then uh, uh, I should have back another 50 rupees note. So this divisibility. So if you see here, gold is moderate, so it is high. And if you see all the trades, cryptocurrency is high in all the trades. Okay, and it is only low in here. That is government control. Okay. So now, advantages: cryptocurrencies hold the promise of making it easier to transfer funds directly between two parties without the need of a trusted third party like a bank or credit card company. This is the main advantage because it is a distributed. You can buy or sell your cryptocurrency. You need to rely on the bank because in financial system, current physical financial system, what we have to do if my money is exhausted, then I have to go to bank and then I have to take the money from the bank. That is, there is a central agency I need to rely on. Okay, now, these transfers are instead secured by use of public key and signature, and by obviously by proof of work or proof of stake. Okay, so consensus mechanism and cryptocurrency. In cryptocurrency, you can use digital wallets. So, cryptocurrency based wallets are now come up in the market. So, you have Paytm. So, it is an example, and the main disadvantages, let me tell, disadvantages, since it is not controlled by government agency, so some uh, illegal activities are there. Particularly, if you heard about ransomware, so this type of ransomware payment are done in cryptocurrency. So this is the main disadvantage, that it's not controlled by government economy. Now, what is crypto economics? So, crypto economics is a cryptocurrency economics, or crypto economics is the economics of cryptography based currency and network. So, rather than being a subset of traditional economics, crypto economy is a mix of game theory, mechanicism design, mathematics, and other methodologies for field of crypto economics. So, crypto economics is not about building a blockchain or building about a cryptocurrency. It is a much complex things. Okay, so participation of various bitcoins are there in the crypto economics. So game theory is there and mathematics is there, obviously. The main goal is to understand how to find, design, develop, and facilitate the operation of a decentralized network. So why crypto economics come? So now I have a one block. Suppose I have created a blockchain. So I have a one. It is okay now. It will gradually increase. So when this gradually increase, then my obviously my network cost, my operation cost will increase. Then it needs to fund this block, my blockchain. And if I able to fund this blockchain or convince the people that, suppose if you purchase my unit of amount, you will get a reserve of 0.1 gram of gold. So this is where if I make my blockchain sellable, or if I sell the sellable, then I manage to fund my operations of my blockchain, and I can also take the profit. Or gradually, blockchain not about central agency, so gradually other nodes will come in this blockchain, and gradually we fund this blockchain through currency. Okay, so this is basically crypto economics. Now, cryptocurrency economics focusing on creating economics incentive. So, incentive is there so that people make eager to participate in the blockchain or Bitcoin or cryptocurrency. So these are direct of the behavior of buyer, seller, service provider, and other parties in the network. It is also popularly known as economics, which is economy of the, and crypto economy is becoming uh, economy of the future. Now this is just a 10 top 10 cryptocurrency, and their values are there. So obviously, Bitcoin is the oldest one and most first comes first position in the cryptocurrency. Then Ethereum, Ripple, Bitcoin Cash is there. So Bitcoin Cash is basically a hard fork of Bitcoin. Okay, so these are the 10 cryptocurrencies. And if you see why people are now giving interest in the cryptocurrency, you perhaps seen the advertisement of Kube Switch, Bitcoin Kharida Kya, something like that. So if you see here, this is the last 10 year, means last 10 year performance. So if you see Bitcoin get the maximum performance than all these things, okay, in the market, obviously in the market, okay. Now coming to the developers. So in the first part, I just give you the guideline how you will become a developer. Okay. Now, if you remember in the last point, I had told you that hands-on experience. So there are so many developer network are available in the market. So I will basically discuss about two. Okay, so first in Solana Developers Network. So you can join here in this website, in their website. Okay, so Solana is a public blockchain platform. Okay, it is a open source decentralized with consensus achieved using proof of stake and proof of history. Okay, so Solana has a typically one unique type of. So I have already discussed proof of stake. Okay. So another is there proof of history. So proof of history is basically the sequence of computation that can provide a way to cryptographically verify passage of time between two events. Okay. So more you can read in here. So proof of history is basically authentic a blockchain based on history of that node. Okay, so if I am a regular, some history based on my history, some computation is done, and then my block is added. It uses a cryptographically secure function written so that output cannot be predicted from the input, and data can be timestamped into a sequence. So every blockchain have timestamp. So these are the main three aspects of Solana Developer Network. Okay, Solana have their own cryptocurrency which is known as SOM. Okay, and Solana can interact with smart contract, and Solana claims to be the fastest blockchain in the world. And now the exchange rate, I just read it in September 2021 that one Solana is about $157. So now it is very cheap, and gradually it will increase. Okay, so this is the basic architecture diagram of a Solana. Okay, so if you are the user, okay, these are the verifier and these are the generator. Okay, so user first give the block adding request or transaction to the generator. Now generator relays this to the verifier. So these are the actually the verifier or the mine. Okay, they verifies and then again they translate back this block to the user so that every user can add this block to the blockchain. Okay, so this is the basic architecture of the Solana. And next is Cardano Developer Network. So Cardano is another fastest growing platform. It is also a public blockchain platform. It is an open source decentralized. So since it is open source, so you will get many things free there. Okay, to develop there. It can facilitate peer-to-peer transaction and internal cryptocurrency. So Solana have Sol and the Cardano cryptocurrency is ADA. Okay, and it was founded in 2005 by Charles Hoskinson, and now it is about one ADA is about $2.06. It is very cheap, and it is fastest growing. And see here, dollars 4.16.45 billion of Cardano already sold as per the Binance. You know, Binance is a very good financial analyzer. Okay, so now this is the basic architecture of Cardano. So in Cardano architecture, we have the nodes. Okay, and inside every nodes, this runs. Okay, so nodes have the process. So process, it have CLI, it have wallet background, it have DB sync, it have post SQL. So this part is basically the database part. Okay, so we are storing the blocks, many blocks. So it is the database part. Okay, now coming to each one. So, what are the node process, CLI, wallet, and database part? These are the main three components running in your node or Cardano node. Okay, so nodes are responsible for executing the outdoor protocol, validating product blocking, and providing information. Command line interface CLI is query the node of information, submit the transaction, build and sign the transaction, manage the cryptographic key. Wallet is there which gives you the amount of Solana or sorry Cardino, that is how many other ADA you are storing or how many ADA you have purchased or sold. Okay, and DVSync is basically operation with the database, and it is based on SQL. You know that. Okay, SQL. You know what is SQL. Okay, and another layer 2 Lightning network just developed by MIT, and I am discussing here because I gave the I had this reference from that it is the lightning network because layer 2 lightning network is, for example, you have a blockchain, you have a bitcoin. Okay, so nowadays bitcoin is so huge and transaction number of nodes are so many that if you want to purchase this amount of bitcoin, that is less than 0.01 cent, then you have to wait for 10 minutes, at least 5 to 10 minutes. Okay, so MIT built this lightning network, so transactions are occurring in this network and blocks are added after that. Okay, so this is the main thing of the layer 2 lightning network. It is very scalable. Okay, so in summary of part 2, we have come up with cryptocurrency as a decentralized blockchain and which is a virtual currency. We studied top 10 cryptocurrency. The cryptocurrency has many advantages, and the only disadvantage it is out of government or central control, and which is the basic definition of a blockchain. Crypto economics in an economic facilitated by cryptocurrency, and we understood two fastest growing developers networks, Solana and Cardano, with their top level architecture, and finally we came across layer 2 because it ran above blockchain, which is a lightning network solution from MIT, which makes the Bitcoin transaction much more faster. Yeah. Now, in the my last part, coming with the some of the concept related to cryptography or that you need to understand before going to the blockchain study. Okay. So, first is modular arithmetic. So, modular arithmetic is any arithmetic in this form that r equal to m mod n or r equal to x to the power c mod n. So, in every cryptographic algorithm, specifically in public algorithm, this modular arithmetic is very important. Okay. Now there is a very interesting algorithm, square and multiply algorithm, which calculates this value. Clear. Now, in if you heard about, I don't know if you gone through the RSA algorithm, then you see RSA algorithm is having a bits of 1024 bits, both for private and public. Okay, so this C is basically uh, 1024 bits. Okay, so this is very huge number. So how we can calculate this one? Because if I multiply C that times, sorry, X C times that, my I need a much more resources to compute this thing. So square and multiply algorithm is there. So basically what we do, we convert this C in the terms of 1 and zeros. Okay. Now the square and multiply algorithms is called. So what is the output? Output is x to the power C mod n of this algorithm. Okay. So initially I assigned Z equal to 1. So Z will be my final output. Okay. Now I traverse this C bitwise, okay, from MSP to LSP, okay, from CK1, CK minus 1 to C0. Clear? So if it is 0, then Z is only squared and mod n is calculated. Z is squared and mod n calculated, okay. And if it is 1, bits is 1, this power bits is 1, so what we have to do? We have to square it and then we have to perform Z into X mod n. Okay, so if it is 0, only square is done, and if it is 1, this bit length is 1, then square and multiply is done. So if you see, this computation is much lower than computing x c times. Okay, and finally we have the Z output. Now there is an interesting thing. Obviously, since this is talk for the student, I have excluded the research part, but I given these things here. So side channel attack is a very interesting thing in cryptography or cryptanalysis. So suppose I am the node which I am deciphering. So if you recall RSA, this C is private. Okay, is a component of my private key. C is private. Okay, so C is only known to me. So I am applying this algorithm. Okay, to for the deciphering or decryption. Okay, now, if you see, suppose an opponent placed a heat sensor beside my laptop or beside my processor. So, if you see, if I sense the heat, then for square I will have a one peak, and for square and multiply I will have two peak, two consecutive peak. Okay, so I easily guess, if I place a heat sensor, then I can guess the private key of that machine. Okay, of that node. That is, it is 0, it is 1 and something. So how we can overcome? We can overcome by introducing a dummy operation here in the else part. Okay, so then what will happen? To speak with will always be there, but there is a trade-off, because when you are a dummy operation, it is consuming your power. So it depends on how security you need. Okay, so in a defense sector, you can use this one, but in other sector, you can omit this one. Okay, so it depends on the need. So this is gone through. So just we've gone through square and multiply algorithm. Now coming to the concept of block cipher. So what is a block cipher? Block cipher is basically a pseudo random permutation. Okay, okay. Before coming block cipher, so pseudo random permutation is a permutation which keeps k and x as an input. Uh, k is of length n, so there is a 0 1 of length n. N number of 0 and 1s is there, and x is L length, so n L number of 0 and 1s is there, and that defines an output. This gives an output which is y, which is of length L. That is, this is this length. Okay, so you know NPR. So permutation, n is the value, p, and r is the my permutation permutated factor. Okay. Similarly, here also pseudo-random permutation. So why it is pseudo-random? Well, it is think of that y is my random number. Okay. So when you place many pseudo-random number at a time in a same block, then it becomes a strong pseudo-random permutation. Okay, and this is basically a block cipher. So if you heard about this or data encryption standard or TDES or anything, so you will see there are many rounds. So why many rounds? To make it a strong syndrome of computation. Okay. Now coming to the cryptographic hash. So cryptographic hash is basically a mapping of arbitrary input length to a fixed length output. Okay. So these are the properties of mapping from variable length message to a fixed length output. So this is hash code HM. M is a message and H is a hash code. And it is a one-to-one mapping. So for same arbitrary length, there will be a same fixed output and it is not reversible. That is, you can traverse from arbitrary length to fixed length, but you cannot traverse to fixed length to arbitrary length. And two different messages do not have same cryptographic hash function. And cryptographic hash function is extensively used in block cipher. Okay, and what hash algorithm you use depend upon this value. The durability or number of blocks of your blockchain depends. Okay, so this is the main concept. Now coming to example, so symmetric key is a cryptography where same key is used to encrypt and decrypt, and this is an example of data encryption standard. Okay, and in asymmetric key there are two keys. Basically encryption is done by receiver's public key. So this is my source, this is my destination. So encryption is done by destination's public key, and when the ciphertext reaches destination, he uses private key to decipher this message. Okay, so one of the extensively used public key cryptography is RSA is obviously there, and electric curve cryptography is there. So electric curve cryptography is basically this way. So electric curve are this type. When if you place a constant value, then curve is like that, and if you have no constant value, then it will be like that. So based on the elective curve, we calculate our keys. Okay, so there are various point operation. Based on this point operation, the private key and public key are calculated. So there are some point operation like point at infinity. So finding the point at infinity, zero or identity element, point of negation, point of addition, point of doubling, point of multiplication. Point of multiplication is basically double and add. Okay, now finally coming to the Markle hash tree. So this is the tree which uses in the uh, blockchain scenario. Okay. So what is Markle hash tree? So this is your data. Okay. So L1, L2, L3, L4. This is a typically binary Markle hash tree. Okay. NRE Markle hash tree is also there. Okay. So typically in binary Markle hash tree, that was proposed in the Bitcoin. So in binary Markle hash, you compute the hash of each of these values. Okay, and then in the next no next level, this is the hash of previous two hashes. This is the hash of previous two hash, and then final hash is calculated. So why this tree is needed? One is to authenticate blockchain with a block without downloading total blockchain. Okay, so you know that my previous block has is that value. Obviously, now my new blockchain value is either greater than that value or less than that value. It depends upon the mechanism of that blockchain. Okay, so this is why one is the important thing. So that Markle has T. Another is so you cannot deny or alter your transaction once it is added. So if you alter this will not match. And sometimes if you attack and alter this and make this as per this L1, this hash is as per this L1, then obviously this hash will not match. So this is the main advantage of Markle hash tree to make your blockchain or your Bitcoin not immutable, and that is why you can not double spend your Bitcoin. Okay. So important is obviously there. The provides a means to maintain the integrity is held in memory or disk space as the proof. Their proof and management require information, and examples are there for Markley who's hasty. So typically, okay. So suppose we have four transactions to be stored. So in the previous example, in the previous diagram, what I have on I have explained. This is the basically example. So leaf nodes are transaction, then the hash nodes are created, and this the tree is created, and block header is finally added as a sorry in the top hash is added basically as block header of your blockchain. Okay, so that's all. So in the last part we have came upon the understanding of what I have not written. So in the last part, we came upon the understanding of cryptographic part. That is, uh, we first studied modular arithmetic. Then we came to know what is a block cipher. Then we hash an example, and finally Marklet hash. Now this reference section, so in any blockchain paper or any cryptocurrency based paper or in talk, Satoshi Nakamoto references obviously there, and these are very good references you can go through. Okay, these are about all these blockchain references, these are about cryptography references, and these are about cryptocurrency references. Okay, and another references I have used, there are very technical details you can find here in the ISO documentation about blockchain, and they update obviously after 1 year or 2 years. So you will get a good reference here. Every technical detail about blockchains. Okay, thank you. So that's all from my side. And if have any question, you can ask me.
Okay, thank you so much, sir. That was a great lecture. And it seems that there are no questions from the audience at this time. But if you have any questions, please feel free to reach out to him through his email ID. And Aditya, could you drop it in the comment section? And well, the
On
recording of this lecture will be available shortly. Yes, sir.
and one thing I
The
want to tell
recording of this
everyone, if
lecture.
ek minute, Homanti, sorry, ek minute. One thing I want to tell everyone, if anyone is interested to collaborate with me in blockchain field of research, then you can contact me in the given email ID. Okay. Thank you, Homanti. You may
Okay,
continue.
sir. Thank you, sir.
Thank you.
Yes, sir. Yes, sir. Thank you, sir. So, the recording of this lecture will be available shortly on this channel and the YouTube channel of GNX CSE. Before we end, make sure you subscribe to our YouTube channel, and if you haven't yet, follow us on our social handles and subscribe to the channel as well. The links to our Facebook and LinkedIn pages have been provided in the comment section below. And apart from this, we are bringing forth to you a feedback form. This form will be active till the next hour. Please go ahead and fill it. This would be of great help to us. Well, this marks the end of today's session. On behalf of everyone, I would like to thank Professor Rajdeep Chakraborty again for taking time out and being here today. Thank you so much, sir. And it was a
Thank you.
great learning experience. Thank you, sir. And for everyone else, thank you for supporting us by joining in. We hope to see you again next time. And until then, stay safe and goodbye.